In this video we are going to explore the topic of partial derivative as well as solving some exercises to explore the topic in more depth. So to start off, we're going to define what is a partial derivative. And a partial derivative of a function of several variables is the derivative of the function with respect to one of those variables while keeping all other variables constant. Formally, suppose we have a function f defined on and upon set U in n-dimensional real space, and a point in an U where I consist of coordinates s sub 1, s sub 2, up to sub n. The partial derivative of f at point A with respect to the ith variable x sub is defined as a limit as h approaches 0 of the difference quotient. The difference quotient is the value of f at the point where the ith coordinate is a sub I plus h, and the other coordinates remain fixed at sub 1 through a sub I minus 1 and a sub I plus 1 through a sub n, minus the value of f at point A, all divided by h. In simpler terms, we vary only in the ith coordinate by a small amount, h, keep the others fixed and consistent, and see how the function changes per unit change in the coordinate as an h becomes a very small number, basically. The symbol for partial derivatives is the curly D symbol called partial, and the partial derivative of f with respect to x is written as the partial derivative of f with respect to x of f sub x. Now we are going to explore some key theorems and properties. So 1. The existence and continuity. Even if all partial derivatives of f with respect to each variable exist at point A, the function f need to be not continuous at that point. However, if all partial derivatives exist in a neighborhood around point A and are continuous there, then f is totally differentiable at point A, and the total derivative is continuous. In this case, f is said to be a C1 function, meaning it is continuously differentiable. 2 is linearity. Partial derivatives are linear operators. That means the partial derivative with respect to x sub I of a linear combination of functions at times f plus b times g equals a times the partial derivative of f with respect to x sub I plus b times the partial derivative of g with respect to x sub I, where a and b are constants. 3 is product rule. If u equals f times g, where f and g are functions of x and y, then the partial derivative of u with respect to x equals the partial derivative of f with respect to x times g plus f times the partial derivative of g with respect to x. Now we have the quotient rule. If u equals f divided by g, where g is not 0, then the partial derivative of u with respect to x equals the partial derivative of f with respect to x times g minus f times the partial derivative of g with respect to x, all divided by g squared. And to finish this off, we have the chain rule. For example, functions say z equals f of x and y, where x and y themselves depend on another variable, the same, x equals g of t and y equals h of t, then the derivative of z with respect to the t equals the partial derivative of f with respect to x times the derivative of x with respect to t, plus the partial derivative of f with respect to y times the derivative of y respecting to t. So more generally, if x and y depend on variables u and v, then the partial derivative of z with respect to u equals the partial derivative of f with respect to x times the partial derivative of x with respect to u plus the partial derivative of f with respect to y times the partial derivative of y with respect to u. So to summarize, partial derivatives generalize the concept of derivatives to functions of multiple variables, to say it some way, and they measure how a function changes as one variable changes while holding the others fixed. They obey similar rules to ordinary derivatives, including linearity, product rule, quotient rule, and chain rule, and continuity of a partial derivative implies total differentiability and smoothness of the function.
Partial derivative by definition. The derivative for definition when is x is lim when tends to 0 is f plus 4x plus 8 and y minus f for x and y. This is between and 8. When derivative if y is lim when to 0, f for x and y plus 8 minus f for x and y between 8. This is the definition of the derivation. One example is x and cube plus 2y squared minus 3x plus 4y minus 5. The derivative definition is x lim when x tends to 0 is x plus 8 and cube plus 2y and square minus 3 4x plus 8 plus 4y minus 5 minus x cube plus 2y squared minus 3x plus 4y minus 5 and between 8. Lim when x tends to 0, the result is x cubed plus 3x squared 8 plus 3x 8 squared plus x cubed plus 2y squared minus 3x minus 3x minus 3 8 plus 4y minus 5 minus x cubed minus 2y and the square plus 3x minus 4y plus 5 and between they cancellate x and cube and minus x and cube they cancel plus 2y and square minus 2y and square they cancellate minus 3x plus 3x they cancellate and 4y minus 4y they cancellate and final is minus 5 plus 5 they cancellate between 8 and the result is lim when x tends to 0 8 for 3x squared plus 3x 8 plus 8 squared minus 3 and between 8 to the cancellate 8 and 8. The result is lim when x tends to 0. This is 3x squared plus 3x 8 plus 8 squared minus 3 and the result finally is 3x squared minus 3. This is for x. This is derivation for y is lim x tends to 0 is x and cube plus 2 for y plus x squared minus 3x for 4 plus y4 minus 5 and minus 4x cubed plus 2y squared minus 3x plus 4y minus 5. And this part is the cancellation and equal and this part lim when x tends to 0. X cubed the cancellation minus x cubed plus 2y squared minus 2y4 x squared minus 3x the cancellate plus 3x plus 4y and minus 4y they cancellate and finally minus 5 and plus 5 they cancellate between 8, and the result is lim when x 10 to 0 is 8 for y plus 2 to 8 plus 4 cancellate, and this 8 and this 8, the result is lim x 10 to 0. 4y plus 2h plus 4, 2h is equal and 0. And the result, the derivation, and y is 4y plus 4.
For the next problem, imagine you have the next function f to x comma y, it's equal to minus x cubic plus 6x squared per y squared plus 5y squared rule square. The next step, you draw and or write the next expression. In this case, you need the partial derivation to x. In this case, halves minus 3x square root plus 2 times 6xy square root plus and that's all. Simplify this equation, this result halves minus 3 times x square root plus 12x y square root, and the partial derivative is this for the x. The next step, it's find the partial derivative of y for the same equation. We'll have in this case this equal to 0, this equal to 2 times 6x quadratic y plus 2 times 5y. The second step, we will have 12x square root y plus 10y, and this is the partial derivative for this function. This answer to x, and this is answer to y, and that's up.
Now we are gonna finish by explaining one last exercise. So we have a function of two variables x and y defined as follows: f of x comma y equals negative x cubed plus 6 times x squared times y squared plus 5 times y squared. Our goal is to find the partial derivatives of this function with respect to x and with respect to y. And step 1 is to partial derivate with respect to x. To find the partial derivative of f with respect to x, we treat y as a constant and differentiate it term by term. The first term is negative x cubed. The derivative of negative x cubed with respect to x is negative 3x squared. The second term is 6 times x squared times y squared, and since y squared is constant with respect to x, the derivative of 6 times y squared times the derivative of x squared, which is 2x, multiplying we get 12 times x times squared. The third term is 5 times y squared, and since this term does not depend on x, the derivative with respect to x is 0. And putting these things together, the partial derivative of f with respect to x is negative 3x squared plus 12 times x times y squared. The second step is to partially derivate with respect to y. To find the partial derivative of f with respect to y, we treat x as a constant and differentiate term by term. First term is negative x cubed, and since it does not depend on y, its derivative with respect to y is 0. The second term is 6 times x squared times y squared, and since x squared is constant with respect to y, the derivative of is 6 times x squared times the derivative of y squared, which is 2y. Multiplying we get 12 times x squared times y. The third term is 5 times y squared. The derivative with respect to y is 5 times the derivative of y squared, which is 2y, giving 10y. Putting these things together, the partial derivatives of f with respect to y is 12 times x squared times y plus 10y. And the final results tell us that the partial derivative of f with respect to x is negative 3x squared plus 12 times x times y squared. The partial derivative of f with respect to y is 12 times x squared times y plus 10y. And with that, the exercise is finished, and that's everything about this topic for today.